Hello friends, welcome you all. So today's topic is number category, and we're going to learn in this session what is a number, why are the different categories of the number, why we require different categories, and why the mathematician or the number of people who are working on the mathematics terms or expressions discovered or invented these different categories. What are these different categories? Examples and some practice examples from these categories, and how these categories are different from each other. So all these number types and number categories we are going to learn in our today's session. So one point to be noted down here is number categories are nothing but the number types only. So let's get started to our session. As we already know friends, what is a number? Number is a unit, object, arithmetic value, symbol, which is useful in counting and calculation. So when we say a word calculation, so it means we are going to use it in a mathematical calculation, or we are going to use it in our day-to-day operation. For example, counting something, counting a money, or mathematical operations are like addition, subtraction. So we are just adding things and getting the result like this. So we have our real-time number system which we are using, and we discuss in our previous lectures also that what is the number system we are using. Then why we need the different categories of the number, because now we are familiar with the number, we are using it for the counting, we are using it for calculation, we are using the number in our day-to-day life. Then why we require different categories of the number, and what are those categories? Before going to answer this question, if you understand different categories of the number, then it will be easier for you as well to answer this question. So let's get started with first, what are the different categories of the number? So let's understand first what are the different categories of the number. So here we have a diagram which is on the screen. So at the top, as you can see, we have written a numbers, means we are covering all type of numbers and we are indicating it in a red mark at the top as a numbers. So all the numbers which are present are classified two categories, which is a real and imaginary. So we are just considering all the numbers which we know and classifying it in a step-by-step manner. So the broadly classification at the top, real and imaginary, then that classification goes down in further. So we decided to understand this thing in levels, because multiple classification has done for the numbers, and there are multiple categories of the numbers are also generated. So if you want to understand this friend, you need to understand different levels or different types of the numbers in a section wise or a level wise. So let's divide it in a different level wise. So let's call it first level at the very top as a real and imaginary. So numbers at the very top are get classified into real and imaginary. Then let us call the real number, as you can see from the diagram, is get divided into two categories, which is rational and irrational. Means a real number is also having a two types, rational and irrational. Let's call it as a level 2. Then at the level 3, we have again a division of a rational number, which is into the part of integer and fractions. And again integers get divided into two types, which is whole and negative numbers, which we have at a level 4. Then level 5, we have whole numbers which get divided into natural and zero. As we all know that whole is nothing but the natural number having zeros, means including 0. So that is, we get split out here. Whole get divided into natural and 0. And we all know that 0 is a separate entity which doesn't have a value, which doesn't have any sign with it. And who invented the 0? That is also you know. So at the level 6, the natural number get classified into two parts, which is even and odd. And again, last level, which is level 7 for us, which is a division of even or odd, or categorization of even and odd into prime and composite section. So at the level 7, we will going to understand what is a prime number and how even and odd get classified into prime wise, and how the numbers which are not prime are called as composite. So this complete diagram, friends, going to cover all types of numbers with explanation. So let's start our explanation so that you will get understood all these different types. So welcome to the explanation board. So as we discuss in our diagram, which you can see on the screen also, we have a different levels. So let go level wise for the better understanding. So as we know, or as you can see in the diagram shown on the screen, we have a level 1, and on the level 1 we have uh, two broad categories of the numbers. So we can say numbers can be categorized into two parts. Numbers can be categorized broadly in the two part here, which is a real number and a imaginary number. Imaginary numbers. So friend, what is a real number and what is an imaginary number, and how this concept of real and imaginary comes into picture? So one might heard about, or you might aware about, a term called complex number. Okay, so we can consider likewise a complex number as numbers only. And how this is possible? Let's understand this. So here let us consider a complex number first. So what is a complex number, friend? Complex number is having particular format of representation. So for example, this is our complex number, and complex number is represented in the form of real number, which is indicated. So let's understand this. Real is indicated by RE word plus imaginary parameter multiplied with again a real number. So complex number basically we can explain in our simple format is a plus ib. But here point to be noted is, what is a and what is b? A and b both here are nothing but the real numbers only. But this doesn't cover our point of real and imaginary. But let's understood it one by one. The complex number is a combination of real and imaginary. Yes, it is okay. So if it is a combination of real and imaginary, this is must be equal to the numbers, because numbers is also classified into real and imaginary. So we can say complex number is nothing but the numbers. Okay, and the representation, this is a unique representation for all the categories of numbers. So this is a unique representation or common representation, we can say, for all number. Then how we can conclude what is a real and what is an imaginary number? So let's understood in this way. Consider this a plus ib form. First understood what is real and imaginary from the complex number definition. So let us take this definition of complex number format, which is a plus ib. If I consider this a as a zero value every time, if I consider this a as a zero value for every time, so if I consider a as a 0, a is equal to 0, or a does not exist, what this equation gives to me? This equation gives to me as 0 I cross b, which is ib as a result. So this imaginary number is multiplied with a real number. But we cannot say this number as a real, because the imaginary parameter is attached with the real number. So this is purely imaginary number. So from this we have clear our definition of imaginary number. So what is the definition of imaginary number we have cleared here? The definition of imaginary number is obtained by multiplying imaginary parameter into or with the real number. Then what is a real number? Because now we concluded or came to the conclusion of imaginary number. Then what is a real number? Okay, from the complex number definition itself, try to understand what is a real number. The real number is nothing but the same way we can obtain the real number. Let us take here a plus ib again and consider b is equal to 0. Then what number remains is a only, and the imaginary parameter automatically gets 0 as I, that is imaginary parameter, is in multiplication with the b. As this real number goes 0 or does not exist, then this term automatically goes away and we only left with the real number. And in this way we can obtain a real number from the complex number system. But this is a definition from the complex number. We require to understand in actual what is going to happen when we're going to consider a real and imaginary number. So let clear this tool out. You can take a screenshot before I clear this out. Okay, now understood friend, again a difference between what is a real and what is a imaginary number. So what is a real and imaginary number? So from the complex number definition itself also, I think it is clear to you the real number is not having any imaginary parameter, and it is not having such a thing that anyone need to imagine or assume something. But in the imaginary, we have imaginary parameter and we need to assume something, some value to get into conclusion. For example, what is the use of it? What is the use of it? Let us understood in this way. There is expression. Let us consider that expression is in quadratic equation, and one mathematician or one person solving this quadratic equation having a conclusion like there is a need to solve the square is equal to -1, and he want to proceed with this expression, and he just assume the imaginary parameter to proceed it further, and that imaginary parameter we are getting with I only here, and this I we are having replacing this x retaining as I square is equal to -1. People oftenly called it as iota. So this is nothing but our imaginary content or content in a quadratic equation or any expression to solve this expression further. So we just assume this parameter in place to get an expression format, because it is very difficult to find x is equal to under root of -1 and any value which is in multiplication of under root of -1. So to solve this expression, we just assume this value and consider it as imaginary value. But why we consider this? If we consider this, are this value or is this value going to convert into real value? Yes, exactly, because if you consider I is equal to under root of -1, and if you square this on both sides, it will give you again a real value which is a -1. So this imaginary value is ultimately going to convert into the real value, right? So that is, there is a no risk to imagine such a thing in a expression. That's why they assume and use this imaginary parameter. So I hope you understand what is a basic difference between real and imaginary. What is real and what is imaginary? So real is not having an imaginary content. Real is not having imaginary content. So real is not having imaginary content first of all. So we are going to understand here a real and imaginary number. So real is not having the imaginary content first of all. This is a basic difference. Okay. So real is not having any imaginary parameter and it is having an imaginary parameter. And what we learn about that imaginary parameter, that is a iota, that is a small I. Here we don't have to imagine anything to get into the expression or get the output of the expression. Here we need to imagine or assume something or some value, right, to conclude our expression, and that is a basic difference. And These real numbers are always used in our day-to-day life. Imaginary numbers are mostly used in our mathematical expressions. Okay, this is a third difference we can say, and we can conclude in this way that real and imaginary are differentiated, but they are united in a complex number, format, which is having a real and imaginary both. So that is the reason the number is called as a complex number at the start. Okay, so this is a basic difference between real and imaginary. Now let us understand more on this point. So what is, if I say the real number, what are the example of this then? What are the real numbers then? And what are the imaginary numbers then? If we are differentiating and we know they are having a difference of imaginary parameter between them. So let's understand what are the examples. Real number, we can term -1 as a real number, 0 as a real number, 5 as a real number, 72 as a real number, 3.28 as a real number. And then what is an imaginary number? Imaginary number can be any real number having imaginary I with it. For example, 2i, 3i plus 5 plus or minus 6i, anything like etc. So this is the basic difference between real number and imaginary number, and that is why real numbers are having all the different categories. Imaginary number is not having, because imaginary number is not a separate section. It is just that we are having in addition a imaginary parameter. Okay, that's it. Then according to representation of real number and imaginary number, what we can show, let us understand in this way, friend. A real number, how we can understand a real number? A real number can be understood and can be visualized from the graph, right? We all know how to plot a graph. We all know on the graph system we have one horizontal axis and we have one vertical axis. So horizontal axis we always name it as x, and this is as a y. On the real number system, this is origin, let us consider, and this is origin at the point. Okay, so on the real number graph or real number system, we have all the real values. Horizontal axis is also representing the real values and vertical axis is also representing the real values. So let us represent real as a RE here. So all they are representing the real values only. So this is 1, 2, 3, 4 positive side, 1, 2, 3, 4 positive side. This is negative side -1, 2. This is negative side -1, 2, -1, 2, and 3. So all these values are only changing the signs, means positive side, negative side, but to plot the value point or indicate the line in different quadrant. So that is the main purpose of graph. And in the real number system graph, we have all the real values, and real values are always indicated with RE word. This just keep in mind, real values are always indicated with RE word. Then similarly, what happened in imaginary number system are also plotted on the graph. But the difference between the graph is, in this case, the horizontal axis, which is x-axis, is representing the real number, but the vertical axis, which is a y-axis, is representing the imaginary number. And here always keep in mind the imaginary number is represented by Im. And what is the imaginary number? The definition comes again here. The definition is a real number into imaginary parameter, which is iota. So friend, we have cleared out multiple things about real and imaginary numbers. So first thing we learn about numbers is, numbers are nothing but the complex numbers, and how we can derive a real number and imaginary number from the complex number system, which is a form of a plus ib, and which is shown on the screen like this. And we know that a is a real number, b is a real number multiplied with imaginary parameter. And we also derived what is a real number to be obtained from the complex number, what is the imaginary number to be obtained from the complex number, by putting a is equal to 0, b is equal to 0, or a does not exist and b does not exist condition. Currently it is having both. That is why we are calling it as a complex, because complex means it is a mixture of real and imaginary, both values in addition format. So real numbers are represented on the graph and imaginary numbers are also represented in the graph. We have seen both things. Now learn more about what is the imaginary parameter. As we discussed, imaginary parameter is called as iota, and as we also discussed that we use imaginary parameter because we get a condition of under root of -1. And why we use these imaginary numbers? Because on squaring on this both side, we will get this imaginary number to be turned into real number of -1, as you can see on this picture. So this is the basic difference between real number and imaginary number, why we have imaginary numbers and why we have a different category of real numbers only. I hope this explanation will get clear you everything about different categories, real number, imaginary numbers, and their uses and application and why they are invented. Now let's move further. Our second level. So friends, in our first level we have discussed real number and imaginary number. Now in our second level we have two different categories of real number only. So in our second level we have real number to be categorized into two parts. First part is rational number and the second part is irrational number. Two part, or we can say a two type. So what is a rational number and what is an irrational number? Let's understand this. So rational number means what comes in our mind when we hear a word rational. Rational means the number which is having the representation in the format of numerator and denominator. Means the rational number is always represented, friends, in the format of numerator and denominator. Let's indicate numerator by n here and denominator by d. So if I say a number is represented in the format of 5 upon 1. So here 5 is the numerator and 1 is our denominator. But we all know if 1 is in the denominator, the number comes out to be same, which is present in the numerator, and that is our 5. So these kind of number, friends, are called as a rational number. If you don't understand thing, let us take another example. Let's first understand rational number. Permanently keep this in mind, friend. Rational number is always in the form of numerator and denominator. And there are two conditions for the rational number to satisfy this format of numerator and denominator. First condition is denominator should not be equal to 0 and the format should be numerator by denominator valid 1. Okay, so these two conditions are present, then we can term this number as a rational number. But what happens if we perform a division between numerator and denominator? As we all know, denominator is present at the base because to divide the upper value. For example, let us take 5 and 2 is there. The 2 is present as the denominator, which indicate we need to divide a 5 by the 2. Means we need to make a part of number 5 in two parts because we have at the denominator side 2 number is present. So let us understand in a division concept. So in a division concept, if we divide 5 in two parts, we will have 5 can be picturized as get divided into 2.5 and 2.5. So this explains that 5 get divided into two parts. But what the division come to us is 2.5, and this division is not repetitive and having a fixed value. This is not going to happen that I divide a 5 by 2 and the value keep on changing. No. So these two conditions must get satisfied if you want to divide further a rational number and to indicate it as a rational number. So if these two conditions also satisfied and these two conditions also satisfied, we can terminate a given number as a rational number. So friend, what is a rational number? Let's revise. So rational number, we will need to have a rational number as four things to get valid for the rational numbers. So any number we can call a rational number as, first thing, if it is present in numerator by denominator format. Second thing, denominator should not be equal to 0. Third thing, numerator and denominator format should get valid. Fourth thing, the after division, whatever the fraction value comes out, it should not be changing. It should not be in a changing format. Once one might ask, right friend, why the value will get changed? Are there any fractions which are keep going on changing? Yes, there are some fractions, friend, or there are some values which keep on changing, or which are recursive in format, or which keep on changing their values. So what are those particular values? For example, let us take a pi value. You all know the value of pi is keep going on different and different. It is not just 3.14, it is 3.14 and having continuous values, again changing and again repeating the values. It is not going to stable at any point. So this condition, if you satisfy, or if your number satisfy, then that number is a rational number. Now understood what is a irrational number. The irrational number, as we take an example of pi, that condition is needed for the irrational number. So what is an irrational number? Irrational number means a number which is having a value changing and which is also in a format of numerator denominator, which is also having denominator not equal to 0, which is also having numerator and denominator valid thing, but only difference is the value keep going changing. So only difference is this. So difference between rational and irrational in a short is, we have for the rational and for the irrational, numerator and denominator, both things are common here. Denominator not equal to 0, same for the irrational. Numerator and denominator must be valid. Numerator and denominator must be valid. But here the value obtained in fraction is not changing. Not changing. And here the value keep on changing. The example for the rational is, you can take a perfect fraction, for example 5 by 2, which is equal to 2.5, or you can take 1 by 6 as well. It is nearly 1.6666 something. One might ask question that it is having a value 1.6666 continue, but it is a recurring value, friends, not a changing value. 6 is going to appear every time, so you can use it as 6 bar. So it is also a rational then. It is changing, so you can take an example of pi here, which is continuously going to change 3.14 for something, but for our mathematical expression we use 3.14. So this is second level description in our video, that is rational and irrational. Now let's move to third level, which is our classification of rational number into integers and fraction. So how rational number get classified into integer and fraction, and what is integer and fraction? So let us understand in this way. Integer is a number which looks like a stand-alone value, That value is always present in a format like it can be a minus, minus 3, minus 2, minus 1, it can be 0, it can be 1, 2, 3, 4, something, but it is always present in a stand-alone format. And the fraction value, it is always in a fraction format. For example, we divide 5 by 2 and we will get a value as 2.5. So this is a fraction value. So fraction value is represented into the point format or into the fraction format. If you don't want to represent it into the decimal format, you can just keep it as 5 by 2. This also is your fraction value. So fraction means there is a complete system present and you are using a part of it. That is called as a fraction. There is a complete number present and you are using a part of it. That is a fraction, and that can be indicated by dividing in a decimal value, or can be indicated in numerator denominator format, which indicate that out of 5 as a complete number, I am using a second part, that is divided by 2. Hence we are calling it as a fraction. And number integer is nothing but the standalone value, which is represented like this. So let's clear out this difference in one go. So what is integer and what is fraction? So integer, we have friends, integer, and we have fraction. So integer are nothing but the standalone values. Standalone values, they are not represented in any decimal format or any numerator denominator format. They can be represented into numerator denominator. For example, we have integer values -3, -2, -1, like 1, 2, okay, 56, like this. They can be represented into numerator denominator format, but the denominator is fixed, that is 1. Okay, because ultimately we are going to give this -3 as a standalone value. So integer is a standalone value which is represented in this format, not having any decimal, not having any fraction values. And fraction is nothing but it can be represented or multiply represented as a numerator denominator format, but here denominator is not equal to 1 and not equal to 0 as well. It is always having some fraction value. That fraction value means maybe a decimal value or any point value, because you are dividing a whole number or a complete number into parts, and that is called as a fraction. So this is a basic difference between rational and fraction, friends. I hope you understand. I will write it again for you. Okay, just indicate a difference. So here we are having integer fraction. Remember it as a value which is not a fraction or not a part. Complete value you can understand like this: -3, -2, -1, 0, or like 56 positive values like this. And fraction is a part of something. Fraction is a part of something. For example, I have 7 divided by what is 2. So answer is 3.5, which is a decimal value, but this 3.5 is a second part of 7, means complete 7 is like this, and I have 3.5 to indicate the 7, like you can understand likewise. So this is, each part is called as a fraction. Now I hope this part is also clear to you, level 3. Now let's move to our next level, that is level 4. What is level 4 and why we are getting level 4? Level 4 is nothing but the integers are again categorized into whole and negative numbers. So what is the whole numbers and what is the negative numbers? Friends, just now we have discussed that integers can be a standalone value, right? I hope integers can be a standalone value. It can be a minus, that is a negative number, -3, -2, -1. It can be 0, or it can be any positive number. Okay, any positive value like 56 or something, 97, and up to this. So integer comprises of complete range from negative, 0, and positive, and that is the reason we have divided integer into a two part, which is 0 as a separate part and natural number as another part. So what is a 0 and what is a natural number? What is a 0? Answer is simple. This is a 0. Do we call everything as a natural number? Yes, every other thing is a natural number here. Okay, so this is a 0 and every other thing is a natural number. So let's conclude level 4, which is a division of whole and negative first, and then whole get categorized into natural and 0. So what is whole and what is negative? I hope you understood. This section is whole because we need 0 as a separate part and we need natural number as a separate part, and negative numbers we are keeping at a separate. So we have classification at the level 4 as whole number and negative number, and that classification is very simple, friends. What is that classification? That classification is, we have a whole number and a negative number. So what is a whole number and what is a negative number? So whole number comprise 0 and natural numbers, means counting numbers. So can we use a negative numbers for counting? No. So we are excluding that in a second part. That is the reason we have 0, 1, 2, 3, 4 up to the counting numbers part here, and here we are using a negative numbers only as a separate section. So this is a complete level 4 understanding and difference between whole number and negative numbers. That is a category or type of integers. So as you can see on the screen, so level 5 is nothing but the categorization of or division of natural numbers into, or the whole numbers into natural and 0. That is a, you can see natural and 0 at a different categories or different types on the level 5. So we have seen that integers are divided into whole and negative. Whole numbers are comprising of 0 and positive, that is 0 and natural numbers are nothing but the counting numbers. So we can differentiate for the level 5 as, or we can write for the level 5 as the natural number as one part and 0 as another part. And we know that 0 is such a type of entity which doesn't have a value and also don't require any sign. Any sign means it is not either a positive or not either a negative. And the natural numbers are always termed as a counting numbers. Okay friends, these natural numbers are always termed as a counting numbers because these natural numbers are nothing but the 1, 2, 3, 4 and so on, and these are always used for the counting or calculation purpose. So these are also not covering the negative parts. So it is having a real time day-to-day life application. For example, you need counting numbers or counting multiple things. You need this natural number monetization purpose, right? So money related purposes. So natural numbers are mainly used for the counting and our day-to-day life. And 0 is such an entity which is discovered by the Indian mathematician, which is don't having any value, but it is also not having any sign related. So it is placed in origin. That is the reason it is considered as origin, because this is origin of everything which don't have either a negative side or either a positive side, and which don't have a real and imaginary concern. So it is at the origin level which originates every we can say a system. So it is placed at origin, which is a 0. So this is a basic difference between natural number and 0, which is a category or which is a type of whole number. Now let's understand a next level. Next level is level 6, where we are dividing natural numbers or parting or making a partition of natural numbers, or we can categorizing the natural numbers into even and odd. So let's understand this first, friend. What is even number and what is an odd number? So there is a very interesting way to understand it. So I hope everyone knows 1, 2, 3, 4 up to 10. So let's write it down. 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now observe the screen carefully and observe this number carefully. Now I am going to denote, before going to understand, just observe what I am going to denote. I am going to denote one kind of numbers with a red color. So 2, 4, 6, 8, 10, and another one kind of number by, let's suppose, a green color. 1, 3, 5, 7 and 9. So what you conclude from the circling of the number, or what you observe on the screen? You observe on the screen the alternate numbers, the alternate red and green are present. Alternate red and green are present. So what if can I say to you that a red number is indicating even and red number is indicating even and a green number is indicating a odd number. So you can find out, friend, that continuous natural numbers we have, and in this continuous natural number we have every alternate number as even, odd. So this is odd, then the even number is present. If this is odd, then the even number is present. If this is odd, then the even number is present. This is odd, then the even number is present. And this is odd, then the even number is present. So we observed that in the natural numbers, we have every alternate number to be placed like even and odd, even and odd, even and odd, like this. So this is a combination of even and odd making our natural numbers, and that is the reason natural numbers are categorized into even and odd format. But what is this even and odd exactly? Okay, now come to the main point. What is even and odd exactly? So even are those numbers which are divisible by 2, and the number itself in exact what? In exact integer. For example, let us suppose I divide 5 by 2. I won't get an integer. I am getting just a fraction value, 2.5. So this is not our even number. But if I divide 6 by 2, I am getting an exact integer value. Exact integer value means it is not a fraction value. It can be a minus, plus, because that depends on what number with sign you have in the numerator. But exact integer value we are getting here. And this means the number is exactly divisible by 2 and also by the 1. So this is a main definition of even number for us. So we can try out some examples. For example, let us take 56. Is it an even number? Let's try to divide it. When we divide it by 2, we have 28, which is exact integer. So it is an even number. What happened with 100? Yes, it is giving exactly 15. So we can conclude the even numbers are exactly divisible by the 2. And what are those examples? To understand the examples, let us write some examples. So let us take some example as in even numbers we can have a number which are divisible by 2, like 2, 8, 14, 94, 100, 160, 210, etc. Now let us understand what is an odd number. Odd number is the number likewise even they are not divisible, unlikewise even they are not divisible by the 2. So not divisible by 2, not divisible by 2, but divisible by which number? But the divisible by number itself, and 1, and any odd number we can add it, any odd number. For example, let us consider this is a 7. 7 is not divisible by 2, correct? This follows if we divide it. When we say not divisible by 2, this doesn't mean that it is not divisible. We are trying to convey here, even though they are divisible by 2, they are not providing an integer value. So you can add this in an odd number definition. So even though it is divisible by 2, it is going to provide 3.5, which is not an integer value, and hence it is not an even number. So it is an odd number. First condition gets satisfied. Second, whether it is divisible by self, yes, it is divisible by self. Whether it is divisible by 1, yes, it is divisible by 1. Whether it is divisible by odd number, 7 is odd number. So this condition is also get satisfied. So we can say here the even number as the number which are divisible by 2, and provides integer as output, provide integer as a result. Okay, and also divisible by itself and 1. And what is an odd number? Odd number are divisible by 2 and provides fraction. So better we can say not divisible by 2 completely or correctly, or for providing integer, providing integer. And we can also call a later more addition to this definition as divisible by itself and odd number. So friend, this is a complete differentiation between even number and odd number, and we also seen what are the different examples of even number and odd number. Now let's move to next level. So next level is even prime, even composite, odd prime and odd composite. So before going to the category of even prime and even composite, or category of odd, that is odd prime and odd composite, let's understand first what is a prime number and a composite number. So friend, what is a prime number? So prime number, it having a unique definition and it is a unique category. It is having a unique definition and it is unique category and also an interesting category. What is a prime number? As we seen, even and odd number definitions such like even are divisible by 2 and number by 1 and also by itself. Odd is divisible by 2 but not providing an integer, so cannot be completely divisible by 2, and providing divisibility by odd number and itself. Likewise, prime number is also having its own definition, and that definition is prime number are divisible by very carefully, see very carefully and observe it, by 1 and the number itself. That's it friend, and the number itself. That's it. Not by the 2, not by the any other thing. Prime number are the numbers which are divisible by 1 and the number itself. So what are the prime numbers? What are the list of the prime numbers? Can we find out the list of the prime numbers? Let's do it. Let's find out the prime numbers between 1 to 100. So what are the prime numbers between 1 to 100? 1 is a prime number or 2 is a prime number? Let us consider 2 as a prime number. So 2, then 3 is a prime number. Can we consider 3 as a prime number? 3 is odd number, that is okay. But 3 is a prime number. Yes, it is divisible by 1 and it is divisible by 3 only, not other number. So 3, then 5. Can we take 5? Then can we take a 7? Yes. Can we take 9? 9 is an odd number, that is fine. But 9 is divisible by 1, that is okay. By 9, that is okay. But also by the 3. Hence, this is not a prime number. So we will eliminate this from the prime number list. So 9 is not a prime number. So we are trying to find out prime numbers between 1 to 100. So after 7, likewise we have 11, we have 13, we have 15. No, it is divisible by 5 as well and 3 as well. So we have 17, we have next 19, then we have 21. No. 23, yeah, it is fine. 25, no, it is divisible by 5 as well. Then 27, no. Then we have a 29, yes. 31, yes. 33, 34, 35, 36, 37, yes. 38, 39, no. 40, 41, yes. 42, 43, yes. 44, 45, 46, 47, yes. What is a prime number? Prime number is a number which is divisible by 1 and the number itself. Okay. And what is a composite number? The composite number is the number which is present in between the range, but the number is not prime. Present in between the range, but the number is not prime. Means, in a simple definition, we can say numbers which are in between the range but other than prime, other than prime only. Okay. So this is a difference between prime and a composite number. Now let's see what is even prime, even composite, odd prime and odd composite. So friend, even prime and even composite. So let's understand in this way. Let's take a number 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now make a 4 category. What are those 4 categories we have? That is even prime. Then we have even composite. Then we have odd prime. And we have friend odd composite. Right? So first identify, before going to even prime and even composite, focus on the first word. What is the first word? First word is nothing but the even. Here in the case even. So let us identify even number first. So what are the even numbers? Even numbers light on this top. What are the even numbers? 2 is even number, 4 is even number, 6 is even number, 8 is even number, and 10 is even number. So even numbers I have written on the top of even prime and even composite. Now filter out which are the prime numbers from it. So prime numbers. So as we all know, and we just now discussed, the number which is divisible by itself only and by 1 only, which is a prime. So 2 is divisible by itself and 1. So it is a prime. Okay. But what about the 4? 4. What about the 4? 4 is divisible by 2, 4 and 1. So it is not even prime. It is also not even prime because it is divisible by 2, 3 and 6 and 1. It is also not the even prime because it is divisible by 2, 4, 1. So it is also not in the category of even prime because it is also covering 2, 5 and 1. So only one even prime we have find out. And rest we have to put it in the composite number because we have a definition, the numbers which are in the range. So this is our range, but not the prime. So these are not the prime. So put it into the composite. So 4, 6, 8 and 10 is the composite. So I hope you understood what is even prime and even composite and also the prime and composite number. So same thing we have to do, or we have to with a prime number, a odd number. Okay, so what are the odd numbers? Let's figure out odd number first. Odd numbers are 1, 3, 5, 7 and 9. Then what are the prime numbers? Prime numbers are which are divisible by 1 and itself only. So we can terminate it as 1, 3, 5 is divisible by 5 and itself. Yes. And then 7. Yes. But if you think about 9, the 9 is divisible by 1 as well, 9 as well, and 3 as well. So 9 is a odd composite. So this is our level 7 friends, and we have distinguished what is even number, odd number, prime and composite, what is even prime, even composite, odd prime and odd composite. So here are some important points at the end of all 7 levels discussion that you need to take away. First is real numbers are any number which you can think of. And that is true because imaginary number are having a very less section. They are also a part of real number, but just a imaginary parameter is added, which is a iota. Imaginary numbers and having imaginary value and parameter, as we discuss right now. All categories belong to real numbers, as we can see on the screen from the diagram. And you can look out the set which is indicating a line having all different values, all different categories of real numbers, which is also having rational, integers, negatives, 0 and everything. So friends, now we have completed our complete session of number system, from the very broad differentiation of real and imaginary to the very least L7 differentiation of even prime, composite, odd prime and odd composite. So this is it for today friend. Thanks for watching the video. Do share this video of complete number system to the person or people who need a complete description of number system with example and with practice. So do subscribe our channel. Stay tuned.